guys, welcome. In this video I've got a question for you on buffer solutions, and this has been taken from the older syllabus, which is F325. It's also unit 5 of the older syllabus, so June 2015 if you're interested in looking at the actual question, because I've just extracted the information for the question that I wanted to talk about. So particularly this question was really good because it uses your knowledge on not just what a buffer solution is, which is a weak acid and its conjugate base ions, but it's also changed slightly, where they're saying that you're adding magnesium to this buffer solution. So let's try this question, okay? Let's fully read it and then attempt it. So it says a student prepares a buffer solution containing propanoic acid and propanoate ions, and their concentrations are both 1 moles per decimeter cube. He then adds 6.075 grams of magnesium to this 1 decimeter cube of buffer solution, and we need to calculate the pH of this new buffer formed. Now at once there's a lot of information given, okay, so first things first, I would write down the main reaction or the dissociation of the propanoic acid into propanoate ions. Okay, this just helps me visualize better as to what is going on in the reaction, in the question itself. So propanoic acid is C2H5COOH, and it's weak acid, so there's going to be partial dissociation, so it will form C2H5COO negative ions plus H plus ions, and we are given that their concentrations are both 1 decimeter cube. So if the volume is 1 decimeter cube and the concentration is also 1 moles per decimeter cube, then the number of moles, which is N equals C times V, is also going to be 1, okay, for each one of them. So that's like what's present initially, and I like to put it down as sort of an ICE method, where I stands for initial, C stands for change, and E stands for equilibrium moles. Some people also call it Rice method, where R is probably the reaction that they're talking about, but I'm just going to keep it as ICE. Okay, so let's put down 1 over here. Okay, so 1 mole initially present of the propanoic acid and 1 mole of the propanoate ions. Now we're not really interested in the hydrogen ions initially or the change, because we are to work out the pH of this solution, so we are going to work out the concentration of the hydrogen ions using the Ka. Okay, so remember that for this particular reaction, Ka is equal to the concentration of the product over the concentration of the acid itself. So we will use that very soon, but first we have to work out what is the concentration present at the equilibrium. Okay, and remember, I'm talking in terms of moles over here. Okay, so I'm just gonna moles. All right, so now there is something else as well happening, okay, which is the reaction between magnesium and the propanoic acid. Okay, so it's important again to write down an equation for that reaction so that you can see what is the molar ratio between the 2 reactants. Okay, so magnesium will react with the acid C2H5COOH plus Mg, and this will give us the salt, okay, magnesium propanoate, okay, and because magnesium belongs to group 2 and it will have a 2 plus charge, and the propanoate ions have a negative 1 charge. So remember, the formula is going to be C2H5COO2 Mg, okay, plus you're going to get H2 as well. So H2 right there. Okay, so for that reason, once you balance this out, you are going to get a 2 in front of the propanoic acid. So this is important because now we know what is the molar ratio. We are given the mass of magnesium, which is going to help us work out the moles of magnesium. Okay, so that will be 6.075 over the AR of magnesium is 24.3. Okay, and that will give me a 0.25 moles. Okay, right, cool. So now we've got that, and therefore we know that the number of moles which are reacting of the propanoic acid which are reacting are twice as many. So 2 times 0.25, which is just 0.5 moles. And so we know that these many moles of the acid have been consumed, okay, in this second reaction. Okay, so we can say that we are left with 0.5 moles less. Okay, so that's already reacted, so we put it down as a change in our equation back over here. Similarly, because the ratio of the propanoate ions is 1:1 with the acid, it means that 0.5 moles of these will be formed, okay, as a result. So at equilibrium, you're going to be left with 1 minus 0.5, which is 0.5, and 1 plus 0.5, which is 1.5 moles. So this is what you're left with at equilibrium in terms of moles. Now, in such cases, when you have the moles already and you're working out the hydrogen ion concentration, you technically don't have to worry about working out the concentration itself, because the moles will be the fraction will cancel itself out. Okay, so what I'm saying is that if you put concentration as n times v, okay, and n times v, so the v's cancel out because they're the same. All right, so that's basically it. So the number of moles over here is the same as concentration, and particularly for this one, because the volume is just 1, okay? So the concentration of the propanoate ions is going to be 1.5 divided by 1, which is just 1.5, sorry. And the concentration of the acid will be 0.5, okay, moles per decimeter cube. So we've got everything now. We have been given the value of Ka. So we can work out the hydrogen ion concentration by rearranging this equation. Okay, so let's put that down as H plus ion is equal to Ka, which is 1.35 times 10 to the minus 5 times by the concentration of the acid, which is 0.5, over the concentration of the ions, which is 1.5. Okay, so let's work this out. So we are to just type these numbers in, 0.5 and ray. Okay, so let's see what that gives me. Okay, right, so that gives me 4.5 times 10 to the power of minus 6 moles per decimeter cube of the concentration. Okay, so finally now we've got to do our pH, and pH is equal to minus log of the concentration of the hydrogen ions, and that's that right here. So I'm just going to do minus log of my answer, and I am just going to end up getting up to 2 decimal places. So that is going to give me 5.35 up to 2 dP. Okay, so that is it. This is the answer. I hope you understood this solution, and make sure you practice questions like this. You do end up getting questions where an alkali is added to the buffer or an acid is added. So if you're interested, leave a comment below. If you want to see such questions, I'm more than happy to do them. Thank you ever so much for watching, and hope you have a great day.